All right, so this video will help you guys get through today's worksheet. So here we go. Intro to trig ratios. All right. So we're going to start talking about the side lengths. Okay, so we talked about this in the other video. If you took a look at the Pythagorean theorem video, remember if angle A is over here, that means that side A is located across. So the angle opposite, the side opposite angle A, we can call side A. Or we can also call the length BC. Okay. The one opposite angle B, we can call the same way. Okay. This is side B. Okay. Or we can call that the length of AC. And the side opposite angle C, okay, is side C, lowercase c, or we could call that AB, or BA if we want to flip it around. So vocabulary, okay? So remember, when we're working with an angle, we're always going to be talking about, with trigonometry, the acute angles here, never the right angle. We'll talk about that a little bit later. So the side across from the right angle is always referred to as the hypotenuse. The side across from the marked angle, so here angle B, is called the opposite leg, or the opposite side. And the side next to the marked angle, remember next to, not the hypotenuse, so this one is called the adjacent leg. Okay, so hypotenuse is always located across from the right angle. Okay, the opposite side is always, or opposite leg is always located across, like if I shot an arrow out of this angle, it's going to hit over here. And the side next to, but not the hypotenuse, the angle is referred to as the adjacent leg here. And these are the abbreviations we're going to use for these sides. So OPP for op, ADJ for adjacent, and HYP for hypotenuse. Okay, so given this right angle, let's see if you guys can go ahead and label these for yourselves. I'm going to pause it, see what you get. Okay, so starting from angle R, right, across the way, so shooting an arrow out is going to give us the opposite side, okay? The one that's attached to it on this side is our adjacent, and then across from the right angle here is our hypotenuse. All right, so same thing over here. That's interesting. All right, we're going to go with the one that's next door is our adjacent, across the way is opposite, and then the hypotenuse across from the right angle. Good job, guys. All right. So on the next page here, the trig ratios. Okay. So the sine, this is pronounced sine. It's actually spelled S-I-N-E, but the abbreviation shorthand is S-I-N, but we still pronounce it sine, not sin. Okay. Is the opposite leg over the hypotenuse. And I'm going to, you guys fill that out. I'm going to go back and type on this. Okay. So we have the opposite leg over the hypotenuse. All right. And so we actually kind of give this the abbreviation OPP for op, okay, over the HYP. All right. For cosine, this is the adjacent ADJ leg over the hypotenuse. All right. And so if we're using our abbreviations here, we're going to call this the adjacent over hypotenuse. And the last one is tangent, which is the opposite leg over the adjacent leg. So once again, if we're using our abbreviations here, opposite over adjacent. All right. And so some mnemonic devices, some ways that you can kind of remember these for yourself is when I was learning, we learned this word referred to as SOHCAHTOA. So, so sine is opposite O over hypotenuse. Cosine is adjacent over hypotenuse. And then TOA. And so that's how I was taught to kind of remember tangent as opposite over adjacent, just using those first letters to create this SOHCAHTOA. Now, what I started doing for myself was instead of writing it out like this, I started writing it as shorthand like this, SOHCAHTOA. So I remembered that sine is equal to that ratio over h, right? Cosine is a over h, tangent is o over a. All right. And so really what happens is this, okay? If I were to take a triangle, okay, and I know it's a right triangle, we're going to start with creating this right triangle, okay? And I create it so that I have a 33-degree angle here, which makes this angle over here become 57 degrees. I know this has to happen because if this is 90, 33 plus 57 has to also equal 90, so that I have 180 degrees. All right, and let's say we dilate this thing by, a scale factor of 2, right? So we're going to dilate it, or we'll say a half. So I'm actually going to make this, right, twice as small, or however much is small. Okay. What happens is that the side lengths, right, which let's say this was 18, and I made it 3 times as small, this is now 6, okay? And if this side was, let's take another number, 21, right, this is now 7, and this is where it gets interesting because we're stuck now with a third side that's going to not be crazy nice. The square root of 765, awesome, isn't it? That's Pythagorean theorem for you, though. This is going to be that divided by 3. But more importantly, these ratios of these sides have to be equal. So if I use this angle, right, I would know that 18 over 21 has to be the same as 6 over 7. Okay, it's always going to reduce down to that same amount. So if I started with a 33-degree angle, okay, and I knew these two sides, I guarantee you I could figure out this side. And because of how these are scaled up, these ratios, no matter what they were, if this is a 33-degree angle, I can always figure out the side length because I know what the ratio is going to be. It's always going to be this crazy amount. So this is where sine, cosine, and tangent comes in. If I know what the measure of this angle is, I'll always know what the ratio of these two sides are supposed to be. And that's the general gist of SOHCAHTOA here. So when we talk about trig, it all boils down to essentially the ratio of these sides in these similar right triangles. Okay, and so the sine of A in our triangle pictured over here, okay, if we're going to name our lengths here, we know with SOHCAHTOA is going to be the opposite side, right, over the hypotenuse. And so this is going to equal from the angle, the opposite is across, it's over here. So this is going to be BC over the hypotenuse, which is AB. And the cosine of A is the adjacent over hypotenuse, which is going to equal AC over AB. So adjacent is the one that's next to it down there. And then the last one we got is the tangent, which is the opposite leg over the adjacent leg. And so opposite and then adjacent, right, not including the hypotenuse. And so this is going to be BC, right, over AC. And so that is the ratio of the sides here, okay? So what I want you guys to do is just taking a look at the angle that's been referenced here. Could you come up with the ratio of these sides in our triangle? We're going to see something kind of cool happens here. So see if you guys can fill these in, and then we'll talk about it. I'm pausing it. You pause it. Fill them in. All right. So you did the first one. So the sine of A, right, is the opposite. So remember, what's that word again? That's right, it's SOHCAHTOA here, okay? SOHCAHTOA. So the opposite over the hypotenuse, okay? So we do OPP, right? Yeah, you know me, over hypotenuse. And so here the opposite of A is 12 over the hypotenuse, which is 13. The cosine of A is the adjacent over the hypotenuse. The adjacent from A is 5 over 13. And the tangent of A, okay, is going to be the opposite over the adjacent. And so the opposite side from A is 12 over 5. And if we switch now, if we start talking about our reference angle as being B here, right, instead of A, we're going to see some things interesting happen. Now the ratio for sine is still the same. It's still opposite over hypotenuse. But now the opposite side from B across the way, right, is actually 5, and the hypotenuse is still 13, right? For cosine, the adjacent over the hypotenuse, okay, adjacent is next to, so that's the 12 over 13. And for the tangent, that's opposite over adjacent, that is now 5 over 12. And so what we see happens is, right, the sine of A is actually the same as the cosine of B, okay? The sine of B and the cosine of A are the same, right? And these two tangents, okay, let's give me a different color here. All right, these two tangents are actually just reciprocals, all right, of one another. And you say like, well, why does that happen? Remember, when we switch from A, right, being our reference angle, to B, the opposite side from A is also the adjacent side from B. And the opposite side from B is the adjacent side or leg from A. So the opposite and adjacent end up flipping. So that's why, right, the opposite here is actually the adjacent in B, and that's why this happens. We switch from one acute angle to the other, the opposite and adjacent legs are changing, and so we get these two complementary angles here. They have the sine of A is equal to the cosine of B. So why is it that they're the same? All right, and we would just say, as we switch complement acute angles, okay, the adjacent leg and opposite leg change, switch. And so that means the sine of angle A, right, the ratio of the sine of angle A is equal to the ratio of cosine of angle B. All right. On to the next page here. So in the triangle below, we're going to identify these following trig ratios. And so this is all you guys are going to do for homework tonight, okay? So go through, just fill out what these are, okay? And we'll talk about this on tomorrow. All right, and then we're going to do the same thing here, okay? So we want to just go through, and on the next page, all right, would you guys come up with the ratios for sine of D and sine of A here, all right? And reduce them, and then see what we know. So, all right, would you guys do that as well? Do you think this is going to happen, be the same for cosine and tangent? And then afterwards, if you guys just want to take your calculator, all right, let me hold mine up here. All right, so on your calculator, just go ahead and open up a calculator page. To get to the sine, cosine, and tangent menu, if you guys look on your keypad over here, right next to the 7 button, you'll see trig. So we're going to press this, and you'll see all these lovely options. And here's sine, cosine, and tangent. We're not going to use these ones over here. These are called the cofunctions, but we will talk about this a little bit later in the week. Sine inverse or arc sine, arc cosine, or cosine inverse, and then tangent inverse as well. So we're just going to select our sine. We're going to type in 0. Now something else we want to notice. Over here, you guys notice it says DEG. That means degree. We want to be in degree mode, okay? If we're not in degree mode, and if you click on this, so if you use your cursor over here on your calculator and scroll up to the top here and you click it, all right, right next to this is this little wheel, that's your settings icon. And if you go to document settings, we want to make sure this says degree, okay? Also, you might see this as float. That means it'll give you the best representation of decimals as possible. If it's sometimes it'll start off with float 6, which means it gives 6 decimal places. All right. We want to choose float. It gives you the most decimals it possibly can. And here where it says angle, you might see that it might say radian. And we'll talk a little bit later about what a radian is. It's essentially a length of a radius around a circle. And these are the two common options that are selected on your calculator, degree and radian. For our purposes, we want to make sure this is degree. If you switch it to radian, you'll notice that up here it says rad. That doesn't mean cool, that means it's in radian mode. All right, so we're going to go back here, make sure you select degree. We're going to click make default. So just press your tab button on your calculator to get to the make default and click enter. And then does it want it to apply to all your settings? Click OK. So now if we click the sign of 0, we're going to get 0. Okay. If we go to sign of 10, so trig sign 10. Okay. If I were, just so you can see what happens here, if I were to click on document settings and switch it to radian, okay, make default, sure. If I go up and select sign of 0 again, I get 0. And if I select sign of 10, I don't get, I get it. That's weird. It's not the same. Remember we talked about radians, okay, being the length of the radius, and degrees is the turn, like how many slices out of 360 do you need for this to work. So these two things are totally two different meanings. The sign of 10 in degrees is not the same as sign of 10 in radians. Okay, so keep that in mind. So document settings, make sure we're in degree mode, make default, okay. All right, so check to see that it's in degree mode. Now you know how to switch in and out. All right, so just go ahead and write those down, and then you're going to round this to the nearest 10,000. Remember how many zeros are in 10,000. That's how many spots we're going to round to. All right, guys, I will see you later. Have a great day.